Hello everyone, let's start with our next topic, that is bitwise operators. So bitwise operators are used to perform operation on bits. What this means, there are so many type of bitwise operator, majorly I think five. Okay, so the first one is bitwise and, you can call this bitwise and operator. Okay, another one is or operator. This is bitwise or. Another one is XOR operator, that is bitwise XOR. So another one is um, bitwise left shift, and another one is bitwise right shift. Okay, so let's move forward with these and understand each of them individually. The first one is bitwise AND. Okay, so how this bitwise AND works, just a second, sorry. So how bitwise AND works, so to understand this we have to write a simple, let me ask you a question here. 8 and 2. So what this operation means, 8 and 2. Okay, so to solve this particular question we have to understand how to calculate binary. So we have to calculate binary. So let me change this to binary numbers. Okay, so there are different methods to divide a number with 2 and get all the reminders and create a binary, but I'm giving you a simple trick to solve these type of questions. So we are going to start with 1. Okay, write this particular series right to left. Okay, so the first number will be 1. Double this number, it will be 2. Double this number, this will be 4. Double this one, this will be 8. Double this one, this will be 16. Double this one, this will be 32. Double again, 64. Double again, 128. Okay, double again, 256. Double again, 512, and double again, 1024. So you have seen this series before. Okay, so as you've seen 32-bit architecture, 64-bit mobile phones, have you seen this? So this series is used to calculate a binary of a number. So if you want to solve this particular question, you have to calculate the binary of 8 first. So see these numbers and check if what those numbers we should add to get 8. So here there is only one number, that is 1. So we will put a 1 below it. Okay, any other number, 0 will be put it or provided. So this will be the binary of 8. Okay, so this is the binary of 8, 1000. If you want to calculate the binary of 2, so what type of numbers we should add to get 2? So we are going to use this. So let's put 1 below 0 and below 2, and this will be 0. So 1 0 will be the binary of 2. Okay, you can put any number of zeros before any number, just like in mathematics. So this is the final binary of both the numbers. You have to calculate and. Okay, so what will be the AND of these two numbers? So for that you have to calculate or check the truth table. Have you seen truth table before? So truth tables are used in electronics. So in logic gates. So this is the same table. So I'm creating a table for AND. So let's create a table. So 0 and 0. Okay. 0 and 1. 0, sorry, 1 and 0. 1 and 1. So what will be the output of these? So in logic gates, if both the inputs are 0, that means output will be 0. If you find any 0 in the input, the answer will be 0. So consider these values as um, you are giving logic gates are used in the circuits. So if you seen any hardware of the system, that is a green board or a blue board, you have seen the golden lines on it. That golden lines carries what? Electricity, and electricity is what? Flow of charge. So if the charge is flowing, that means we consider that as 1. System don't know about 1 and zeros. It only knows what is the high voltage and low voltage, or if the current is flowing or the charge is flowing or not. So if the charge is flowing, that means we consider that as 1, and if it is not, then we consider it as 0. So if charge is not flowing, or you can say there is a low voltage in both the inputs, the output will be no voltage. Okay, if there is a low voltage in any of the inputs, so the output will be no voltage. Both the inputs are giving the charges, the output will give the charge. So it's like a circuit. So it is used in logic gates. So you can use them. We have to use this particular truth table to solve this question. So 0 and 0, what will be the output? 0 and 0 will be 0. Okay. 0 and 1, this will be also 0. Okay. 0 and 0, this will be also 0. 1 and 0, this will be also 0. So the output should be 0 of the previous question. This. Okay. Once you get the binary, you have to calculate the number as well. So this particular series work both ways. So it's vice versa. If you want to calculate binary of a number, just see what numbers you should add to get the binary. And if you have the binary, just see and check if you put all the numbers, all that binary numbers below them, like 0, 0, 0, and 0. After calculating these numbers, or we are not considering any of them, they are this is the binary of 0. Let's consider one more example. So if you write print um, 11 and 2, okay, so or 3, for example, 11 and 3, what will be the output of this? So let's calculate the binary of 11 first. So binary of 11 will be, let's check which numbers to add to get 11. 8 plus 2, this will be 10, plus 1, this will be 11. So we put 1 below this, 1 below this, and 1 below this. So by adding these numbers, 8 plus 2 plus 1, you will get a 11. Okay, let's put 0 below the numbers that are not considered. So this will be the binary of 11. So 1011 will be binary of 11. What will be the binary of 3? What numbers we should add to get binary of 3? So that will be 2 plus 1. Okay, 2 plus 1 will be 3. 1 1 will be the binary of 3. Let's put it here. Okay, let's calculate and in both the cases. So 1 and 1 will be 1. 1 and 1 will be 0 and 0 will be 0, and 1 and 1 will be, sorry, 1 and 0 will be 0. So in AND cases, in this particular case, if any of the charges are not available, the output will be 0. If both the charges are available, then output will be 1. So in this particular case, the output is this. Let's put this binary below this particular series. So you will get 3 again, as 0 are not considered. 1, 1, output will be 3. Okay, so if you run this, output will be 3. Okay, so this is how this works. So what you have to do, you have to calculate binary of both the numbers, put it like this, just like you calculate sum of particular numbers, and check if there is a um, and logic behind them, and use this truth table to solve it. Once you get the binary, again check it and put it below this particular series, and you will get the output. Okay, so this is how bitwise AND works. Okay, let me break down this particular topic into subtopics so that we can focus on each of them individually. Let me quickly give you some more examples, like 27 and 11. What will be the output of this? Let's solve this particular question. So 27, addition of 16 plus 8, this will be 24, plus 2, 26, plus 1, 27. So we're going to put 1 here. Okay, plus 8, this will not be considered, plus 2, plus 1. So 16 plus 8 will be 24, plus 2, 26, plus 1, 27. So 11011. 11011 will be the binary of 27. What will be the binary of 11? As we already calculated the binary of 11, that will be 1011. Okay, let's solve this with AND operator, bitwise AND. Okay, what will be the output of this? 1, again 1, again 0. 1 and 1 will be 1, and 1 and 0 will be 0. So again the output will be 1011. 1011 is the binary of 11. Let's check, the output is 11. Okay, let me consider one more example. So let's say 31 and 41, or 31 and 25. Okay, so what will be the output of these two? What will be the binary of 31? So binary of 31 will be 16 plus 8, 24, plus 4, 28, 28 plus 3, 31. Okay, so all these numbers. Okay, so 1, 1, 1, 1, 1, 5 times 1. So this will be the binary of 31. What is the binary of 25? So 16 plus 8, this will be 16 plus 8 will be, sorry, 1 and 1. This will be 24, and we have to calculate for 5. This will be 1. 0 will be here, and 0 will be here. So 11, 0, 1. This is the binary of 25. Okay, let's calculate the AND operator, bitwise AND of these two numbers. So 1 and 1 will be 1, 1 and 0 will be 0, 1 and 0 will be 0 again, 1 and 1 will be 1, 1 and 1 will be 1. So 11, 0, 1. This is the binary of 25. So the output is 25. So let's calculate some of questions. So you can try multiple questions here and calculate different binary of different numbers. So try it out. I'm dividing this particular chapter, operators chapter, to multiple sections. Okay, that's it.